Hi guys, welcome back to my YouTube channel. In today's video, I'll be explaining binomial distribution to you. I'll definitely make sure you understand everything regarding to binomial distribution without having to bother about anything. So if you know this is what you're looking for, then watch till the end. Now, the general formula for binomial distribution is n combination x, p raised to the power of x, q raised to the power of n minus x. And the mean of binomial distribution is equal to NP, while the variance is equal to NPQ. So these are the basic things you need to know. Now, in this binomial distribution, one thing you'll be given is your P, okay, and you have to find your Q yourself. And how do you find Q? Q is 1 minus P. So note that the P here is a probability of success and the Q is probability of failure. Okay, so now you'll be given n and you'll be asked to find x. I hope you understand. So now let's talk about the n combination x. So in the question, you come up with something like 5 combination 2, 3 combination 3, okay, and let's say 5 combination 1. So now let me show you how you can actually go about combination. Now the general formula for combination is n factorial divided by n minus x factorial x factorial. That is, we are saying that this will be 5 factorial divided by, due to the n combination x, the n is the 5 and the x is the 1. So divided by 5 minus 1 factorial 1 factorial. Okay, that is, we're having 5 factorial divided by 4 factorial 1 factorial. So this 5 factorial you're seeing can be reduced to be 5 times 4 factorial divided by 4 factorial multiplied by 1 factorial still gives you 1. So 4 factorial cancel 4 factorial. Then we have 5 divided by 1 automatically gives us 5. So this is how to go about solving anything regarding to combination. Okay, so now let's talk about this question here. Question says that the probability that a certain component will survive electric shock is 3 over 4. If 5 components are selected at random, what is the probability that, okay? Now, the probability that a certain component will survive electric shock is 3 over 4. This is what? 3 over 4. So the P is what? 3 over 4. So the Q here can be gotten as 1 minus P. That is 1 minus 3 over 4, which will definitely give us 1 over 4. Now the next line is, if 5 components are selected at random, that is, the end there is 5. Now they said, what is the probability that at most 2? So when they talk about the word at most, what do they mean? At most mean that from 2 downward. Okay, you're starting from 2. So the x there is what? At most 2. X is equal to at most 2. Okay, and the values for at most 2 is starting from 2 till 0. Okay, I hope you know that. So now it means that we are having this to be 0, 1, and 2. So these are the things we need to solve for. Okay, now the general formula is n combination x, as we've said before, p raised to the power of x, q raised to the power of n minus x. Okay, now we need to do for 0, which is 5 combination, what? This 0 here, okay, 0. Now our p, as we've stated there, is 3 over 4. Then the x is 0. Then our q is what? 1 over 4. N minus x, which is 5 minus 0. Plus, we need to do for 1. Okay? Now it is 5 combination 1. 3 divided by 4 raised to the power of 1. Then we have 1 over 4 raised to the power of 5 minus 1 plus, now let's do for 2. 5 combination 2, we have p to be 3 over 4 raised to the power of x, which is 2. Then 1 over 4 raised to the power of 5 minus 2. I hope you understand that. Okay, so now we're having 5 combination 0, 3 divided by 4 raised to the power of 0, 1 over 4 raised to the power of 5, plus 5 combination 1, 3 over 4 raised to the power of 1, 1 over 4 raised to the power of 5 minus 1 gives us 4. Okay, plus 5 combination 2, then we have this to be 3 over 4 raised to the power of 2, 1 over 4 raised to the power of 3. 5 minus 2 will give us 3. So now, doing this in your calculator, this will definitely, now look at 5 and 0 must give you 5, okay? The addition of the powers there must be equal to the upper one there. I hope you understand that, okay? So now, using your calculator to do this, you definitely have 0.000977 plus this will give us 0.01465, okay, plus 0.08775. So adding all of this is 0.1034. So this is the final answer to this particular problem. I hope you understand that. Okay, now let's talk about the B part. The B part is at least 3 components will survive electric shock. That is our X, okay? At least 3 components will survive electric shock. So now we're talking about at least 3, okay? Is equal to 1 minus probability of at most 2. You know that we were meant to do for, okay, let me just say it this way. Now, at least 3, okay? It means that you're doing from 3 till the last number, which is 5. So which is 3, 4, and 5. I hope you understand. But this is actually a long process. Imagine you're doing a CBT course, okay? So one thing I just want you to know is that you can actually do it this way instead of stressing yourself. That is probability of x greater than or equal to 4. Let's assume you can do this to be equal to 1 minus probability of x less than or equal to 3. That is, at least 4 can be equal to 1 minus at most 3. So since we have probability of x greater than or equal to 3, which is at least 3, can be equal to 1 minus probability of x less than or equal to 2. I hope you understand that. So that's a very short way to go about this, because we've done this before. So this is 1 minus 0.1034. That was the answer to that. So this answer will be 0.8966. I hope you understand that. Okay, so without stressing yourself, you can do it this way. So for the sake of practice, you can do for 3, 4, and 5 and see what you actually get. You will realize that the answers will be the same. Okay, so for the sake of practice, you can actually solve that yourself. Now look at this question. The probability that a lab specimen contain high level of contaminant is 0.1. High level of contaminant is 0.1. So the P there is what? 0.1. You are meant to look for your Q yourself, which is 1 minus P, okay, which is 1 minus 0.1. This will give us 0.9. Now the next question here is, the next thing here is, if 5 samples are checked independently, okay, that is, the n is what? 5. Now the question is, what is the probability that exactly one sample will contain high level of contaminants? Exactly 1. Okay, so that is our x. I told you initially that we will always be given the x in the question. So n combination x, p raised to the power of x, q raised to the power of n minus x. That's the formula, which is 5 combination 1. P here is what? 0.1. X is what? 1, okay? Then q is 0.9. n minus x means what? 5 minus 1. Okay, so this will be 5 combination 1, 0.1 raised to the power of 1, and 0.9 raised to the power of 4. Okay, so now using your calculator to solve this, you will probably get 0.3281. Okay, so that's the answer to this question. For the sake of practice, you can try out the B part yourself. You can pause the video to try out the B part. Okay, now, so the B said that no sample will contain high level of contaminant. From the word no sample, it means you're dealing with what? Nothing, which is 0. Okay, so it means you're doing for 5 combination 0. Because the main formula there is n combination x, p raised to the power of x, q raised to the power of n minus x. Okay, so the p there is 0.1, then the x here is 0. Okay, now the q here is 0.9, n minus x means 5 minus 0. Okay, so now looking at this, 5 combination 0 will give us 1. Multiplied by anything raised to the power of 0 is 1, multiplied by 0.9 raised to the power of 5. So multiplying all this will give you 0.5905. So that is the final answer to this particular problem. Please, if you've watched this far, do well to subscribe and like this video so that it will keep popping up for other people to gain from this. So now, this is the last question here. The probability that an entering student in Ilorin will graduate is 0.6. Okay? Then the P here already, you know that it is what? 0.6. And the Q is 1 minus P, which is what? 0.4. Okay? Determine that out of 6 students, okay, which is the n is 6. Alright, so please, at the end of this video, I'll be showing you a trick you can actually solve questions like this. Alright, please do well to subscribe, like, and share this video to your learned colleagues. Okay, so that YouTube will keep recommending this video. Now the n here already, you know it's 6. Okay, now we'll be asked to find the x, which is, they said determine that out of 6 students, none will graduate. From the word none, what does it mean? 0. None of them will graduate. So n combination x, p raised to the power of x, q raised to the power of n minus x. Okay, then it means that 6 combination 0, the p there is 0.6 raised to the power of x, which is 0, 0.4 raised to the power of 6 minus 0, which is still 6. Okay, so we have this to be 6 combination 0, all right, which is 0. The answer of this is 0.04096. Okay, without wasting our time. Okay, so now the next question here is 1 will graduate. 1, just 1 will graduate. So what does that mean? The x here is 1. So we are meant to do for 6 combination 1, then p is 0.6 raised to the power of 1, then q is 0.4 raised to the power of 6 minus 1, yeah, which will later give us 5. So 6 combination 1, 0.6 raised to the power of 1, 0.4 raised to the power of 5. Okay, so now looking at this 6 combination 1 is 6 multiplied by 0.6 multiplied by 0.4 raised to the power of 5. Okay, multiplying all these will give us 0.03686. Okay, so this is the final answer to this particular problem. Okay, now let's solve for the C. The C here is saying that at least 1 will graduate. At least 1 will graduate. Okay, so the x there we are looking for is the p is 0.6, of course, the q is 0.4, our n is 6, and the question they're asking us is at least 1 will graduate. Okay, at least 1. This means that we are meant to do for 1, 2, 3, 4, 5, 6, And that's a very, very long process to go. Imagine you're doing a CBT exam, you will definitely be wasting your time. Okay, but there is a simpler method in solving this. And at least one, okay, means that we can say this should be 1 minus probability of at most 0. As I've stated before. So this can be probability of at least 1 can be equal to 1 minus probability of at most 0. I hope you understand. Because we've actually solved for 0 before. So x greater than or equal to 1 means that 1 minus probability of x greater than or equal to 0. Okay? That is, we can as well say this should be, this should be x less than 1. Because values that are less than 1 is still what? Is still 0. I hope you understand. Okay? We can say probability of x less than or equal to 2, which is at most 2, can be 1 minus probability of x greater than or equal to 3, which is at least 3. So these things, you can use them to save time instead of stressing yourself to solve complex things. So now looking at this, they said x less than or equal to 0. Okay, that is, the only value there is 0. Imagine it was less than or equal to 2. It means that we'll be solving for 2, 1, and 0. But because it is less than or equal to 0, so the only thing we are solving for here, it is 1 minus probability of when x is equal to 0. And we've done that before, which the answer here is 0.004096. I hope you understand. So this can actually save you a lot of time. So this will be 1 minus 0.004096, which the answer will be 0.9959. So this is the final answer to this particular problem. I hope you understand. Thank you so much for watching this video. For the sake of practice, you can actually solve for the D and the E part yourself. I would like to get your answer in the comment section below, and I will definitely be confirming it if you're definitely correct. Okay, so please don't forget to subscribe, like, share this video to your learning colleagues, because doing that way, it will help me to keep posting more videos like this, and this also encourage me to keep doing more contents like this. Thank you so much for watching. See you in my next video.